Hi everyone, you're welcome back to Ismatis. In this video, I'm going to give solution to this indicial equation problem. 4 to the power of x minus 8 to the power of x is equal to 2. Please do well to subscribe to Ismatis. Always like our videos. Then let's give solution to this. We have 4 to the power of x is equal to, minus 8 to the power of x is equal to 2. Following the rules of indicial equation, these are different bases. Let's check if there's a way we can make the bases equal. Yes, here 4 is the same thing as 2 to the power of 2 per x, minus 8 is 2 to the power of 3, then per x is equal to 2. At the same time, I can write this as 2 to the power of x per 2 minus 2 to the power of x per 3 is equal to 2. Since if I have a to the power of m to the power of n, it can also be written as a to the power of n to the power of m according to law of indices. So at this point, I can now say, since I have 2 to the power of x power 2 and 2 to the power of x power 3, there's a similarity here. So I can say, let 2 to the power of x be equal to y. You may call this equation 1 in case you may need it subsequently. Then, having called 2 to the power of x, y, we substitute this into this equation, and we have, at this point, we are writing this as y squared minus, here we are writing this as y to the power of 3 is equal to 2. Alright, we can move on. Here we already have we are having an equation of its highest order, or an equation of the order 3. So I can write this equation this way. When I take the minus y cubed to this side, it will be y cubed, then minus y squared plus 2 is equal to 0. This is a polynomial of order 3. How do I go about this? I will check what we are trying to get. Here we want to get the roots of this equation. We want to get the roots. How are we going to make that possible? The roots of the equation is just anything we can input into this, any value of y that we can input into this equation, and when we put everything together, they all become 0. If I put 1 into this equation, is it possible? No. But if I put minus 1 into this, yes, it is possible. Like if I take minus 1 cubed minus 1 squared plus 2 is equal to 0. Checking this, minus 1 cubed will give me minus 1. Minus 1 squared gives 1 plus 2. Minus 1 times minus 1, minus 1 gives minus 2. And minus 2 plus 2 gives 0. Alright, so at this point, we can see that minus 1 is a root of this equation. And if minus 1 is a root of this equation, then y plus 1 is a factor. Y plus 1 is a factor of this equation. Is a factor of the equation. This we did by checking out the numbers that can work out in this. I know this may not it may have to take you a lot of you thinking on which one will be possible as a root, because we want to break this polynomial down. We want to break it down to make it simpler for us to solve. So y plus 1 is a factor of this. And if y plus 1 is a factor of this equation, what is the other factor of this equation? Alright, without wasting time, we can get the other factor following the long division process. I just wish to take this so that it will be more clearer what we have done. This will be y plus 1 dividing y cubed minus y squared plus 2. Alright, y dividing y cubed gives y squared. Y squared multiplied by y is y cubed. Y squared multiplied by plus 1 give you plus y squared. Subtracting this, y cubed minus y cubed, this becomes 0. Minus y minus plus y squared will give minus 2y squared plus 2. Plus 2, alright. We go again. Y dividing y squared minus 2y squared will give minus 2y. And minus 2y multiplied by y we give minus 2y squared. Minus 2y multiplied by plus 1 we give minus 2y. Subtracting this, we have minus 2y squared minus minus 2y squared, that gives 0. Plus 2, okay, then 0 minus minus 2y we give 2y, because in the first here we don't have any variable containing y alone, so we can just bring out minus multiplying minus is plus, so this will be written as 2y plus, we just bring down our constant 2. Again we can divide. Y dividing 2y we give plus 2. Plus 2 multiplied by y we give 2y or plus 2y. Plus 2 multiplied by plus 1 we give plus 2. Subtracting this we have 0. Alright, so looking at this is the next factor of the equation. That means that y cubed minus y squared plus 2 can be written also as y plus 1 times y squared minus 2y plus 2. We can break this down to this point, and we know that this is equal to 0. We already have that y plus 1 brackets y squared minus 2y plus 2 is equal to 0, which means that at this point y plus 1 is equal to 0. And if y plus 1 is equal to 0, it gives us the first root of the equation which we earlier mentioned, and this will give plus 1 crossing the equality sign will give us minus 1. So this will give us the first root of the equation as y1 is equal to minus 1. Alright, we can also equate the second root of the equation, which is the second factor of the equation, which is y squared minus 2y plus 2 is equal to 0. Alright, before I move on to solve this equation, probably it may be solvable. Of course, it should be solvable. We have a general formula we can also apply, even if it can't be factorized. But let us perform the test. This has formed the quadratic equation, so we can perform a little test on it by checking the discriminant of this quadratic equation. And how do we always check the discriminant of a quadratic equation? We say that d, which is the discriminant, is equal to b squared minus 4ac. Here our a is the coefficient of y squared, which is 1. Our b is the coefficient of y, which is minus 2. B here is minus 2, and c is plus 2. C is plus 2. So we can say that we can substitute all this into the discriminant equation, and we have here that d is equal to minus 2 to the power of 2 minus 4ac, that is a is 1, c is plus 2. And here we can say minus 2 to the power of 2 minus 2 to the power of 2 is 4. This gives 4 minus 4 multiplied by 1 is 4. 4 times 2 is 8. This will be 4 minus 8. And 4 minus 8 gives us minus 4. Looking at this, minus 4 is less than 1 or less than 0. Minus 4 is less than 0. And since minus 4 is less than 0, what do we say about this quadratic equation? We say that there are no real roots of the quadratic equation. There are no real roots of the quadratic equation. Since the discriminant gives us a number that is less than 0, we can conclude by saying that if we solve this quadratic equation, it can never give us roots of the equation as real numbers. It would rather give us roots that might be complex numbers. So at this point, we don't have need solving this quadratic equation. So let us just choose, let us just take y1, which is equal to minus 1. So we are going to have here, at this point, we are going to have that. Okay, so we are now taking y to be equal to minus 1. Therefore, if we choose y to be equal to minus 1, substituting this into our equation 1, which says that 2 to the power of x is equal to y. Substituting y as minus 1, we have this as 2 to the power of x is equal to minus 1. What is the next step we are going to take here? The next step we are going to take here is we take the logarithm. Yes, we take the logarithm of both sides. And taking the logarithm of both sides, I can have this as log 2 to the power of x is equal to log minus 1. And here I can write this as x log 2 is equal to log minus 1. And x will be equal to log minus 1 all over log 2. And in logarithm, we can write this as log minus 1 base 2. This becomes the value of x, log minus 1 base 2. Alright, this is the solution to our indicial equation. You can as well drop your comments or your review about this solution, as we have it here on the board, and we'll always appreciate it. Don't forget, like our videos, subscribe to Ismatics, and always stay connected, as we have lots more to offer you in this channel. Until the next video that will be coming, do have a wonderful moment. Bye.